Hi, welcome back to Find My X Math Tutoring here on YouTube. Today I will be showing you all about end behavior. Here we have our two basic functions, y equals x and y equals negative x. For end behavior, we just have to look at what the arrows pointing off in the distance do. So let's put a box around all of our ends. Those are the only places we'll be looking at. We don't care what happens in the middle for end behavior. That's why it's called end behavior. So here we see that while x is increasing to the positive range, y is increasing to the negative range. And over here, as x is going to the positive range, y is also going to the positive range. And for this box, while x is going to the negative range, y is also going to the negative range. While over here, as x is going to the negative range, y is going to the positive range. Now, let's continue with some other graphs. For these graphs, let's put a box around our ends again. So here, we see that as x is going to the positive range, y is going to the negative range. And here, as x is going to the negative range, y is going to the negative range again. Here, we see that as x is going to the positive range, y is going to the positive range. And as x is going to the negative range, y is also going to the positive range again. Here, as x is going to the positive range, y is going to the positive range. And as x is going to the negative range, y is going to the negative range. But over here, as x goes to the positive range, y goes to the negative range. And as x goes to the negative range here, y goes to the positive range. Now let's take it even a step further. Let's look at these crazy graphs. Let's put a box around our ends again, since that's all that matters with end behavior. Let's take a gander. So as x is increasing positively, y is also increasing positively. And as x is decreasing in the negative direction, y is also going to the negative direction as well. And here, as x is positive, y is positive. And as x is negative, y is also positive again. So now that we've figured out our end behavior for each function, let's go back to the beginning and start seeing if we can put this in some kind of notation. The type of notation I'll teach you today is called limit notation. That's where we put our end behavior into some kind of notation. So to start us off, let's talk about the difference between odd and even functions. Here we have an odd function, which means that the end behaviors are in opposite directions. And here we have a positive end behavior, which means that our ends go in the same direction. So taking it back to our original graphs, let's put this in limit notation. So first we're going to have to write lim, standing for limit, as x approaches infinity. Meaning as x keeps getting positive, what is y doing? So we write f of x equals, and in this case, when x was increasing, y was also increasing. So we'll write as the limit of x approaches infinity, f of x, meaning y, also approaches infinity. And so to complete this notation, we'll write what happens as x approaches negative infinity. And as we said, when x was approaching negative infinity, y was also approaching negative infinity. But for this function, we said that when x was approaching infinity, y was approaching negative infinity. And as x was approaching negative infinity, y was approaching positive infinity. Now, let's take it to the second step that we discussed and do these functions. First, let's determine if they're even or odd. These ends go in the same direction, which means this function is even. In this function, both the ends point in the same direction, which means this function is also even. And since this function has opposite pointing ends, it means it's odd. And the same goes for this function, since its ends go in opposite directions. So now that we know if end behavior is even or odd, let's put it back into limit notation. So for this function, we'll say that as x approaches positive infinity, y approaches negative infinity. And also for this function, as x approaches negative infinity, y equals negative infinity again. Now, let's skip over here to this function. We can say that as x approaches infinity, y equals positive infinity. And as x approaches negative infinity, y also approaches negative infinity. Now that we understand these functions and our basic functions, let's take it to our super weird looking functions. So as you can see, these functions have the same boxes as the ones that we did before. So let's put these into limit notation. We can say that as x approaches positive infinity, f of x also approaches positive infinity. Doesn't matter what's here, just the boxes on the ends. And so we can say that as x approaches negative infinity, y also approaches negative infinity. Now let's move over to our even function over here. For this function, we can say that as x approaches infinity, y also approaches positive infinity. And as x approaches negative infinity, f of x reaches positive infinity again. Thank you for joining me on this journey through mathematics, limit notation, end behavior, positive and even functions. I hope you enjoy the magicality and wonderfulness that is mathematics. Please join me again on another video if you need more knowledge, which you always should need. And just look at more videos for Find My X Mathematics Tutoring here on YouTube. Thank you.